Hello, Matthews Gatos here. In this video, we're going to be talking about the substitution rule, which is the reverse of the chain rule. So let's look at the chain rule. The chain rule is used to take the derivative of any kind of a composite function. So we have a function inside of another function. So let's review how to take the derivative. So the derivative of f of g of x would be the derivative of the outside, keeping the inside the same, multiplied by the derivative of the inside. So using what we know about derivatives and antiderivatives, that would mean that the integral of f prime g of x multiplied by g prime of x dx would just be f of g of x plus c. So I want to find a way of simplifying this process. So what I'm going to do is I'm going to substitute u for the inside function of the chain rule. So the inside function of the chain rule is g of x. So I'm just going to let u equal g of x. Then the derivative of u with respect to x would be g prime of x. So I want to take this and substitute or solve for dx, because in the formula or the expression I don't have a du, I have a dx. So let's multiply both sides by dx, and I would get du equals g prime of x dx, and divide both sides by g prime of x. So I would have du over g prime of x equals 2 dx. So let's go back to the original integral. So the integral was f prime of g of x times g prime of x dx. So by substituting in u here, and we have g prime of x, multiplied by what dx is, that's just du over g prime x, you can see that these cancel, and then we're just left with the integral of f prime u du, which is much easier to work with than what I started with. So looking at the substitution rule, because we're substituting u for the inside function, that's why it's sometimes called u substitution. Now this integration by substitution is best used when you have derivative pairs. Here's what I mean by a derivative pair. I have an inside function that is g of x, and an outside piece that I'm multiplying it by that is actually the derivative of the inside. So that's what I mean by derivative pairs. So substitution is one method of integration, and it's really intended to reverse the process of the chain rule, so that when I have f of g of x, an inside function, multiplied by the derivative of the inside function, it just simplifies to be the antiderivative f of g of x, of course, plus c. So let's look at the steps. So the steps are to recognize what the inside function is and substitute u for that. Then we've just seen that du is just g prime of x. So by substituting those two values in, it simplifies to just be the integral of fu du. So you take the integral of that, and in your last step, you just substitute g of x back for u, and then you have your antiderivative. So let's try an example. So I've got 4x and x squared plus 1 to the exponent of 5. So look for your inside function, and this would be my inside function. So I'm going to let u equal x squared plus 1. Okay, the next thing I'm going to do is take the derivative of u with respect to x, and that's just 2x. So I'm going to solve for dx. So multiply both sides by dx and divide both sides by 2x. Okay, so now I'm just going to replace this here. It's going to be the integral of 4x times u exponent 5 multiplied by dx, which is du over 2x. And if I've done that correctly, I'm only going to be left with u's and du's. So here you can see 4x divided by 2x is just 2. So I can actually take the 2 outside and say that this is 2 times the integral of u exponent 5 du. Well, we know from the reverse of the power rule, this is just going to be 2 times u, increase my exponent by 1, divide by my new exponent, all plus c. So that is going to be, let's make this a little bit bigger. There we are. So that's going to be 2 over 6 simplifies to be 1 over 3. So that's u exponent 6 over 3 plus c. And then I just substitute in what u is. So it's going to be 1/3 of u. And remember, if we go back up here, we substituted u to be x squared plus 1. So this is going to be 1/3 of x squared plus 1 plus to the exponent of 6 plus c. And that would be your final answer. Okay, let's try another one. So I have the integral of cos cubed x sine x dx. And I have a hint there. Remember, anytime we have a number here, it just means, it's an exponent, it really means cos of x all cubed sine of x. And when I write it that way, I can see what my inside function is. My inside function is just cos x. So I'm going to let u equal cos x, and then du by dx is just going to be sine x, but remember the derivative of those c functions are always negative. So multiply both sides by dx and divide both sides by negative sine. Okay, now I'm ready to go back to my original integral. So I have the integral of cos cubed, which is now u cubed, sine x multiplied by dx, which is du over negative sine x. Now I know I chose my u correctly when these cancel and you're only left with u's and du's. So that's a -1, which I'll take out front, u cubed du. So that will just equal to -1 times u to the increase the power by 1, divide by your new exponent, plus c. And then all we have to do is substitute what u was, because we didn't start with u, we started with x's, and u is cosine of x. So this would be negative cosine exponent 4 of x divided by 4 plus c. So you see, by doing substitution, it makes things a lot easier. The only trick is, what do you substitute u for? And the nice thing is, if you make a mistake, you'll find out right away, and you just substitute it in for a different value. Okay, looking at this one here, I have x cubed and e to the x exponent 4. So I already know that the integral of e to the anything is e to itself, but I have an x exponent 4. So what I'm going to do is I'm going to substitute u for x exponent 4. And I know very quickly if I did that right, because du by dx equals 4x cubed. And I see that's going to help me get rid of my x cubed. So multiply both sides by dx and divide both sides by 4x cubed. So like I said, if it doesn't work for you the first step, just try it again with the different u substitution. So now my integral is going to be the integral of x cubed multiplied by e to the u, and dx is du over 4x cubed. So my x cubes cancel. So I'm not taking out a 4, I'm actually taking out a quarter because the 4 was in the denominator. So this is a quarter times the integral of e to the u du, which I know is 1/4 e to the u, because the antiderivative of e to the u is just itself, and then I'll add plus c. And then last step, I just substitute what e was, or sorry, what u was, which is x exponent 4. So this would just be 1/4 e to the x exponent 4 plus c. Okay, let's try one more example. This one here, so I have the integral of x over x squared plus 3. So again, just pick a u to substitute for. So I'm going to try my entire denominator. And I see when I take the derivative with respect to x, I get 2x. And so I suspect that I'm on the right step because that might get rid of that x there. So solving for dx, I multiply both sides by dx and divide both sides by 2x. And I can see I'm on the right track because then I have an x in the numerator and an x in the denominator. So it looks like this might work. So this is the integral of x over u times, instead of dx, I have du over 2x. So I can see, yes, my x's cancel. So I don't take a 2 out, the 2's in the denominator, I actually take a half out. And that's 1 over u du, or u to the negative 1 du. So I can't use my power rule, because if I increase that by 1, it's 0, and divide by 0 is 0. So just think back to what derivative would 1 over u be? And hopefully you're thinking of ln x. Now, it looks like it could be ln x. I'm actually going to go back up to this step here now that I see that the negative exponent won't work. So if I were to write this as ln of u, the reason this won't work is because this has a restriction that u can't be 0, but this has a restriction that u has to be greater than 0. So they both have to be the same restriction. So what I'm going to do, instead of it being ln u, it's going to be 1/2 times ln of absolute value of u, because then my domains will match. So this will just be 1/2 times the natural log of, instead of u, I have x squared plus 3 all plus c. So that, in a nutshell, is u substitution. So I thought this was a really cute joke. I see integrals everywhere. So the integral of ODA is OA plus C. So I see integrals all the time. How often? All the time. So I hope this video on integration by substitution helped. The next video that I'm going to do is integration by parts. So if you liked this video, give it a thumbs up and hit subscribe so you can be alerted to any new videos I create.